Okay, this is going over question number 10 from 4.2. And the question was something like, your numbers might vary because red numbers are randomized, but something like g of x is 5 sine x on the interval from 0 to pi with 6 rectangles. Okay. So first let's do the left approximation. And to do that, let's do the left endpoints. So the first one would be the leftmost point of the integral, which is 0. And then you got 6 of them, so your interval widths are pi over 6, but you already knew that, so it's going to write it down. Pi over 6, and then 2 pi over 6, which would be pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, and then 5 pi over 6. So those are your left endpoints. Let's just go straight to the approximation. So what are we doing? Okay, yeah, we're doing the area, right? From 1 through 6, we got 6 of them, and we've got 5 sine of each of those endpoints times the width. The width is always 1 6 pi or pi over 6. Okay, let's change color. So the first one is 5 sine of 0 times pi over 6. And the next one is 5 sine of pi over 6. So I think you did this already. And then blah blah blah. I'm gonna skip the middle for now, just to save time. And then the last one is 5 pi over 6 times pi over 6. All right. So now let's start plugging these things in. Sine of 0, that is 0. So you get 5 times 0 times pi over 6. Next one, you get sine of pi over 6, which is a half. Like that. Next one would be pi over 3, which at that point sine would be root 3 over 2. So 5 times root 3 over 2. And then next one is sine of pi over 2. So that's 5 times 1. Yeah, sine of pi over 2 is 1. And then sine of 2 pi over 3, that would be tall size with root 3 over 2 again. And then one more, I didn't quite fit in that line. Sine of 5 pi over 6, which should be back to 1/2 again. Yeah, and then times pi over 6. And I think I noticed this in your notes, but you observed that you could pull out the 5 and the pi over 6, right? So you can pull out the 5 because that's common to everything. And then what are you left with? You're left with these guys. Let's use color. Let's use this color. So you're left with this, that, and that, right? So 0 plus 1/2 plus root 3 over 2 plus 1 plus root 3 over 2 again plus 1/2. Okay, so let's just plug this whole thing in. Let's do the calculator. Here we go. So on the outside we had 5, right? And then times, where is it? Pi. Here's some pi. Oh, here it is. Times pi over 6. And then in parentheses we had 0. You don't need to put it, but just put it. Plus 1/2. Plus root 3 over 2. Oops, that's a mistake there. This should be root 3 and then space divided by 2. So I wonder if that was your mistake. I don't know, it could have been the same as me. And then we had a 1. And then we had another root 3 over 2. and then a half. Okay, and the answer comes out to 9.7705 to the nearest 4 decimal places. So that would be for 5. I noticed that you said something about 7.8 something. That would be the answer if this was 4 instead of... If that was 4 instead of 5, then that would be 7.8 something. Here, watch. Let's do a quick check. Yeah, so maybe the wrong number there? I don't know. Okay, that was the left endpoints. Okay, coming back to the question, right endpoints. You correctly observed that it would give you the same value, and that makes sense because think back to what's happening here. Think back to our unit circle. So we're taking the values from, starting from, the left endpoints are from 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Right, those are the left endpoints. And so you're looking at the sign heights at those positions. If you do the right endpoints instead, then you're going to get similar picture here. Let's do it in purple. Right endpoints, the first one would be this guy right here. And then 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And the last one is this. Right, 6 pi over 6 are full pi. But this guy happens to coincide with that first one. And so the result ends up being the same in this case. All right, so that's question 10.